All right, you've got to hear this. So Google just dropped two massive announcements, basically at the same time. And on the surface, they look like they have nothing to do with each other. I mean, one is about this crazy new AI that's solving pure math problems that have been unsolved for years. The other, it's about a gigantic, game-changing battery being built out of Minnesota. But here's the thing. These two stories, they're not just related. They are two sides of the exact same coin.
And it all really kicks off with this quote. I mean, wow. When a guy like Terence Tao says something like this, you just have to stop what you're doing and pay attention. We're talking about someone often called the Mozart of math. So for him to say this, it's not hype. It's a signal that something fundamental is shifting in one of the most difficult fields human beings have ever tackled. So what's really going on here? Well, this brings us to our first story. It's about a brand new AI from Google DeepMind, and it's called Althia. You know, for decades, pretty much everyone agreed that real mathematical creativity, that deep, intuitive leap that pushes a whole field forward, well, that was a line an AI was just never going to cross. This is the story of that line getting completely erased. And let's be super clear here. These were not just, really hard test questions. Althia was taking on open problems. These are questions that professional mathematicians were actively stuck on, problems sitting right at the very edge of what we know as a species. And Althia didn't just find the answers, it did it all by itself with zero human guidance along the way.
To really get why this is such a monster deal, you have to understand the difference between something like a math Olympiad and what Althia is doing. An Olympiad, that's all about using tools you already have in really clever ways, usually under a time crunch. The research frontier? That's a totally different planet. There is no known path to the solution. There isn't even a guarantee that a solution exists. You literally have to discover brand new mathematical ideas just to get started.
So the really amazing thing isn't just what Althia solved, but how it pulled it off. The way it works internally is what makes it so different from anything we'd ever seen before. So let's kind of pop the hood and see what's actually going on in there.
Okay, so picture this. Inside Althia, there's basically a constant, intense argument happening. You got one part, the generator, that's just this wild, creative engine throwing out all sorts of new ideas and crazy-sounding solutions. But then you've got the other part, the verifier, which is like the world's toughest, most skeptical critic. It attacks every single idea. It checks every tiny step of the logic. And if it finds even the smallest flaw, boom, the idea is rejected. Only the proofs that can survive this brutal internal fight ever get presented as an answer.
And this right here shows you one of its most brilliant features. You know how most AI systems will just make stuff up if they don't know the answer? They'll hallucinate something that sounds right. Well, in pure math, that's a complete catastrophe. So for the 4 problems that Althia couldn't crack, it didn't try to bluff. It just stayed silent. In this kind of high-level work, knowing what you don't know is just as valuable as finding a solution. And that restraint is built right into its core design.
So let's take problem 7. It had been unsolved for years. The math itself is mind-bendingly complex, but the basic question was, can this specific mathematical object even exist? Althia came back with the answer, no. But it didn't stop there. It actually proved it was impossible using 2 totally different and, frankly, beautiful methods. That's not just solving a problem, that's demonstrating a deep, genuine understanding.
But, and this is a huge but, that kind of deep insight comes at a cost, a massive one. Just to solve that one single problem, Althia needed 16 times the reasoning budget, the raw compute power, that DeepMind used for another one of its huge AI breakthroughs. I want you to file that number away, 16x, because it's the first real clue that connects our 2 stories.
The researchers who built this are actually calling it the beginning of the end for the manual era of mathematics. For centuries, progress was limited by how long a human could focus or how many bad ideas they'd chase. A system like Althia, it doesn't get tired. It doesn't get bored. It can just grind away at a problem relentlessly for as long as it has power. And that word, power, that brings us to the other half of this puzzle.
Okay, so now let's do a hard pivot. While all of this incredible stuff was happening in the abstract world of pure math, Google was building something very, very real out in the physical world. They announced a new data center that's going to run entirely on clean energy. Now, that part's not totally new. But what is new, what's a total game changer, is what's backing it up. A first-of-its-kind, industrial-scale battery unlike anything the world has ever seen. The tech behind it, which comes from a company called Form Energy, it's so cool. It's basically reversible rusting. So to get power out, little pellets of iron breathe in oxygen from the air and they rust, which releases energy. To charge it back up, an electric current is sent through, which reverses the whole process. It turns the rust back into pure iron. It's simple, it's made from abundant materials, and it is built to be huge.
And this is what truly sets it apart. The typical big lithium-ion batteries that we use for the grid today, they can give you power for maybe 4 to 8 hours, tops. This new iron-air battery, it is designed to provide continuous, non-stop power for 100 hours straight. That's more than 4 days. It's not just an improvement, it's a whole new category of energy storage.
So you might be asking, why 100 hours? What's so special about that number? Well, that's how long you need to get through major weather events, like a multi-day blizzard that covers your solar panels, or a week where the wind just doesn't blow. Short-term batteries are great for smoothing out the day, but long-duration storage like this is what's needed to make wind and solar as reliable 24/7 as a fossil fuel power plant. It's the missing piece of the puzzle for a fully clean grid.
Okay, so we've got a genius math AI on one side and this beast of an industrial battery on the other. It's time to finally connect the dots and see why these are really just two parts of the exact same grand plan.
Let's just ask the question straight up. Why on earth would a company be investing in this very specific, very niche, long-duration energy tech at the exact same moment it's building an AI that needs absolutely insane amounts of compute?
And here it is. This is the answer. That long horizon reasoning, the kind of deep thinking that Althia does, is unbelievably energy hungry. Remember that 16x compute budget for just one problem? As these AI agents get smarter and take on even harder challenges, the single biggest bottleneck, the hard physical limit on what they can achieve, is energy, pure and simple.
So you see, the two revolutions are actually one and the same. If you want to build the next generation of AI, you need systems that can think about a single problem for days, maybe even weeks without stopping. And if you're going to power that kind of marathon thinking, well, you need an energy source that can run for days without a single interruption. Google isn't just building a smarter brain. They're building the physical body required to power it. The mind needs the matter.
And this leaves us with a pretty incredible final thought. For decades, we've thought of the AI frontier as being all about software, algorithms, and data. But we're now entering an era where the frontier is just as much about physics, chemistry, and industrial-scale power grids. The ultimate limit on artificial intelligence might not be our own cleverness, but our ability to feed it. So the question is, what happens when the energy to think becomes almost limitless? What problems will we solve then?